Okay, hypothesis testing, testing a claim about a mean. In previous sections, we tested a claim about a proportion. This is about a mean. So this is our, way to find out the test statistics. In previous section, we found based on the proportion, we found the test statistics z-score. Now in this section we are testing a claim about testing a claim about a mean. So these are the two methods we are going to use for finding the test statistics. If you have student t distribution, and then if standard deviation sigma is not known, then this is the formula we're going to use. Or standard deviation sigma for the population is not known and sample size is greater than 30. This is the formula we're going to use for finding the t-value. And if we have normal sampling distribution, and then if sigma is known and normally distributed population, then this is the formula we're going to use. So we're going to focus on these two statistics formula. So remember, there are two methods we can use when we try to make a decision. One is p-value method, and then another one is critical value method. So in p-value method, after finding the p-value, compare that value with alpha, and based on this comparison we can reject or fail to reject null hypothesis. Similarly, for the critical region, we can reject or fail to reject null hypothesis based on this critical value method. So these are the way to conclude our finding. This is from the first section of this chapter. So in this particular section we try to use population testing a claim about a population mean, and this is one of the most important topics presented in this course. There are two ways we're going to see. One is using the when standard deviation for the population is not known, which is standard way, and then sometimes standard deviation is known, which is very rare. Okay, the objective is use a formal hypothesis test to test a claim about a population mean. These are the symbols we use, and the requirement when we use this claiming method when standard deviation for the population is not known. These are the two requirements we should have. The first one is the sample should be simple random sample, and either the population is normally distributed or the sample size should be greater than 30. So these are the requirements we have to keep in mind. And this is the test statistics formula for finding the t-value, and we are going to use technology, especially for the large data we use the StatCrunch for finding these values. So one more thing, I would like to mention here, requirement for normality or the sample size greater than 30. If the original population is not itself normally distributed, then sample size has to be greater than 30. Sample sizes of 15 to 30 are sufficient if the population has a distribution that is not far from the normal. Okay, in this text we use the simplified criteria of sample size greater than 30. Okay, so this is the information about the student t distribution, which we already discussed in previous chapter as well. Student t distribution is different for different sample size. For the student t distribution, mean should be 0. Standard deviation is of the student t distribution varies with the sample size and is greater than 1. As the sample size gets bigger and bigger, standard t distribution is very similar to the normal distribution. So after that, we try to test a claim about mean when standard deviation for the population is known. These are the requirements you have to check when you use this method. The sample should be simple random, population standard deviation should be known, and either the original population should be normally distributed or sample size should be greater than 30. So this is the formula we use for finding the test statistics whenever standard deviation for the population is known, and we can find the p-value or critical value by using the technology. So these are the things we have to use in this section. Let's go over some problems from this section. So this is our problem 1. 12 different video games showing violence were observed. The duration times of violence were recorded with the times in second listed below. What requirement must be satisfied to test the claim that the sample is from a population with the mean greater than 85 seconds? Are the requirement all satisfied? So as you can see here, it's 1 2 3 4 5 6 7 8 9 10 11 12. The sample size is less than 12. The condition, the requirement should be the sample size should be greater than 30 or normally distributed, and at the same time the sample observation must be simple random. Those are the two conditions we should have. But in this problem, those are the conditions, they are not met. So we don't know either it's from the normally distributed population, the sample size is not greater than 30. So we have to choose one of the no's answers. So no, the sample size is not greater than 30. The sample does not appear to be from a normally distributed population, and there are no observation above 85 seconds. There are some, so this is not the right one. No, the sample size is not greater than 30. The sample does not appear to be from a normally distributed population, and there is not enough information given to determine whether the sample is a simple random sample. It looks right, but let's read the last one. The condition for binomial distribution, it's not needed, so this is the right one. Okay, let's go to next problem. A data set includes weight in grams of 33 Reese's peanut butter cup miniature. So there are 33 data we have given here, not the data but the test statistics. It's given. The accompanying stat display shows result from using all 33 weights to test the claim that the sample is from the population with the mean equal to 8.953 gram. Test the given claim by using the display provided data. Use a 0.01 significance label instead of the actual data. We have given this information, which is test statistics, critical t-value, p-value. These are the information we need to find, but it's already given here, so we just have to construct this null hypothesis and alternating hypothesis. Here we would like to check the claim. Where is the claim? Test the given claim by using, what is the given claim? To test the claim that the sample is from population with the mean. So the sample is from the mean is equal to 8.953. 8.953. That's the null hypothesis. Alternating hypothesis is not equal to 8.953. Remember, always the null hypothesis is equal sign, and then alternating hypothesis could be not equal or less than or greater than. In this case, it's a not equal. Okay, identify the test statistics. It's already given here, so you don't have to use any calculator. It's a negative 2.62 if you round it to the 2 decimal place. 2.62. P-value is already given. If you round it to the 3 decimal place, it's a 0.013. So it's an easy one because everything is given here. But based on this information, now we need to find the conclusion. State the conclusion about the null hypothesis. So look at here. The p-value is it greater than significance level alpha? Yes, it's a greater. So we go back here to make the conclusion. If p-value is greater than alpha, fail to reject null hypothesis. So fail to reject the null hypothesis. So to make the conclusion, you can see here, does the original claim contain the condition of equality? Yes, it's equal. Original claim contains the condition of equality. Do you reject H0? No, fail to reject. This is the conclusion. Okay, sorry, fail to reject a null hypothesis. So this is the conclusion. There is not sufficient evidence to warrant the rejection. So that's supposed to be our conclusion. there is not sufficient evidence at 0.01 significance level to warrant a rejection of the claim. So that is our conclusion. Next problem, we have data looks very, we cannot use a TI-8384 calculator. It takes time to type all these numbers. So I'm going to use StatCrunch to solve this problem. As you can see here, if you want to find out this information, then you need to use the StatCrunch, but this information is already given here, so you don't need a StatCrunch if you don't want to use. But I can show you how you can find this information. Okay, so if you copy and open in StatCrunch, I can find this data is already copied here. I can just go here, stat, and I can find summary stat by choosing the columns. This first column is variable 1, this column. Now when I do compute, it gives me all the information I'm looking for. Look at here, what is that? So there are, okay, so as you can see here, it's going to give me the mean, which is 12.19. That's the mean, 12.9. It's already calculated, it's already given, but I'm just trying to show you how you can use StatCrunch. So that's the sample mean. The sample size is 36, and sample standard deviation is 0.093, as you can see here. So all this information can be found by using StatCrunch. So now, but it's already given, so we don't have to do it here for this particular problem. So what is the null hypothesis? Null hypothesis is mean should be equal to, according to this problem, it should be equal to 12 ounce, right? It's a 12 ounce. The alternating hypothesis is mean is not equal to 12 ounce. What is the claim? Just read the claim. Assume that a simple random sample has been selected. Test the claim that cans of the Coke have a mean volume 12. So alternating means it's not equal to 12. Now find the test statistics. So for finding the test statistics, as you can see, you can use this formula manually by using your TI-83 calculator, TI-83 or TI-84 calculator. You can use this formula: sample mean minus population mean divide by sample standard deviation divide by square root of n. Or you can also use your StatCrunch. So I'm going to use StatCrunch here. So how do you do that? So it's already copied in StatCrunch. We would like to find out, go to the stat, go to the tstat, one sample with data, click it, select the first column, which is variable 1 column, and then hypothesis test is, we want to, our null hypothesis is mean is equal to 12, and alternating hypothesis is not equal to 12, and our critical value, as you can see here, the significance level we have given here is 0.05. So now if you compute, it gives you sample mean, standard error, degree of freedom, t-stat. You see here, t-stat, that's the test statistics, which is 12.60. 12.60. Especially StatCrunch is very useful if you have the huge data like this, and if you have to find this information manually, then instead of finding that manually, you can use the StatCrunch. So what is the p-value? P-value, if you can go here, it gives you the p-value less than 0.0001. If you round it to the 3 decimal place, the p-value would be 0. Now the conclusion thing, look at here, p-value is less than significance levels, so it's less than alpha, so reject the null hypothesis. And now it's yes, reject the null hypothesis. So this is our conclusion: there is sufficient evidence to warrant rejection of the claim. So we go back here, reject the null hypothesis. There is sufficient evidence at the 0.05 significance level to support the claim that, no, what is that? Did I do something wrong here for the conclusion? Does the original claim contain the condition or equality? Yes. Do you reject the null hypothesis? Yes. There is sufficient evidence to warrant rejection of the claim. Warrant rejection of the claim. There is sufficient evidence at the 0 level to warrant rejection of the claim. And now, so after that, it does not appear. Remember, the claim is the mean volume should be 12 ounce, but in our sample the mean volume is greater than 12 ounce, and we are rejecting this claim. But as you can see here, it doesn't mean that the mean is less than 12 ounce, because the sample mean gives us the mean is greater than 12 ounce. So it appears that it does not appear that consumers are being cheated, because the consumers are getting at least 12 ounce. So this alternating, after rejecting the null hypothesis, you are going to support the alternating hypothesis. I mean, not the support, but failing to reject the null hypothesis means, what is the alternating hypothesis? Alternating hypothesis is it's not equal to 12, but based on our sample, it's greater than 12. So at least consumer are getting at least 12 ounce of this 12 ounce of Coke. That means it does not appear that consumers are being cheated. Okay, let's go to next problem here. Using accompanying 200 Los Angeles commute time. So this looks big data. You see here, it's a 200 data, so we cannot do it manually one by one. So I'm going to use StatCrunch. That's the reason I use StatCrunch to find out the information here. Okay, these are the 1200 data set, and now I have a StatCrunch, so I can use this. So what is the goal here? The claim is that the mean Los Angeles commute time is less than 36 minutes. So the claim is the mean is less than, that's the claim. So the claim is less than 36 minutes. So the null hypothesis is equal to 36, and claim is less than 36. That's the claim, less than 36. Always remember, null hypothesis means equal, and then alternating hypothesis means it's a claim. Assume that a simple random sample has been selected. So it's given. Use 0.01 significance level. Compare the sample mean to the claim of 36 minutes. And let's check it first. Good job. Identify the test statistics. If you go to your test, StatCrunch, go to T-stat, one sample with data, and select this first column, which is variable one column. Our null hypothesis is equal 36. Alternating is less than 36. Our critical value significance level, as you can see here, it's a 0.01. And now just compute. It gives you sample mean. Sample mean is 32.91, and T-stat is negative 1.71. So that is our T-stat, negative 1.71. Test statistics. What is the p-value? If you go back to the p-value is 0.044. 0.044. And this p-value, as you can see here, it's a greater than the significance level. So whenever the p-value is greater, that means fail to reject. And in this case, there is no equality for the claim. The claim is less than, so we go to this direction, and we are rejecting the null hypothesis. So the answer is fail to reject. Okay, fail to reject, because p-value is greater than alpha. Fail to reject. So this would be our conclusion. There is not sufficient evidence to support the claim. That is our final answer. So fail to reject. there is not sufficient evidence at 0.01 significance level to support the claim. Okay, now the sample mean is this many minutes greater or less. So as you go here, you can find out the sample mean, which is 32.915, and then population mean is 36. So you can subtract this to value. I can just use calculator here. So it's a 36 minus 32.915. So it's a 3.1. Round it to the one decimal place. So it's a 3.1 minutes. So this sample mean is 3.1 minutes less than the claimed mean. As you compare your answer, you just subtract. It's a 3.1 minute less than the claimed mean of 36 minutes. This difference is not statistically significant because this is within the range of that 2 times standard deviation.